Okay, so in this video, we are going to talk about the intro to Arccosine. And if you watched the previous video on Arccosine, then you would have gotten to see the basic intro to what inverse trig functions are and why we need things like domains and ranges. So if you haven't seen that, go check that out. But what we're going to talk about here with arccosine is what values are we going to be limiting cosine to so that the inverse function proves true, and how would we evaluate some of the problems that we are asked with arccosine. So the first thing that we are going to do is let's take a look at what a cosine x graph looks like. Okay, so what are the things that we already know about the cosine graph? Well, I know that it oscillates between 1 and -1, just like a sine graph. And I know that one period lasts for 2 pi. Okay, so and what a cosine graph looks like is starts at 1 and it's going to come down right at the middle. It's going to touch at -1 and then it's going to go up and it's going to finish back where it started at 2 pi. Okay, so halfway through here, right in the middle, that is pi, and at the very bottom is touches down at -1, and it crosses the x-axis a quarter of the way through, so we could call that pi over 2. And it goes back up a quarter of the way between pi and 2 pi, which we could call 3 pi over 4 if we wanted. And no, not 3 pi over 4. That's not right. We would call that 3 pi over 2. Sorry. And so similar to what we did for the sine. The sine graph, well, what we're looking for is we are looking to limit the domain and range so that we have all of the values between 1 and -1 without duplicating any values. So we want to be able to pass the horizontal line test, which will tell us that when we take the inverse of this graph, that it will also be a function, and it will then pass the vertical line test. So the values that we are going to want to designate for this graph are going to be between 0, which is right here, and pi, which ends right over here. So this is going to be the portion of cosine that we are going to want to designate to make an inverse. So let's not turn. So what this is, this means that the domain is going to be between, this is for the inverse of cosine. So for cosine of x, or arccosine of x, the domain is going to be -1 to 1. Again, with brackets to include those numbers because they do actually touch. And where do we go on the x-axis? Well, we go between 0 and pi, because at pi it's all the way down at -1. At 0 it's all the way up at 1. So those are all of the values. So that's how we figure out what the range is going to be. So the range of cosine is going to be between 0 and pi. A little bit different than what the range for sine is. Sine was negative pi over 2 to pi over 2. And the difference between a cosine graph and a sine graph is really just a transformation or a phase shift of pi over 2. But that's for another video. All right, so what is an arc cosine graph gonna look like then? Okay, well, let's take a look. It's going to look like this. All right, so we determined that the domain was going to be between -1 and 1, correct? And the range is going to be between, oh, that needs to be a bracket, 0 and a pi. And a pi also needs to be a bracket. All right, so domain between -1 and 1, so let's call that -1. Let's call this 1. I guess that looks like 1. And the range is going to be between 0, which is here, and pi, which is up here, okay? And if we remember our values for cosine, when at 0, you know, cosine started at 1, so that's now going to be down here, and it's going to go across the x-axis. I know it's a little wobbly, I'm sorry, and end -1 at pi, okay? And this point that it crosses the y-axis, we can call pi over 2, just for reference. So this is what an arc cosine graph is going to look like.